Okay, let's start. Good morning, everyone. Greetings from GirlScript Verna. GirlScript Foundation is India's first and biggest tech community and is working to change lives by imparting tech education and relevant skills. Through GirlScript, we are able to share this knowledge with all of you all, and I hope you guys take something away from today's session. Sanchit, next. Sanjit Parab and I, Riya Patel, are the chapter leads of GirlScript Verna, Region Goa. With us, we have our campus heroes, Sarvesha Ferte and Harmanpreet Kaur from Padre Conceição College of Engineering. They have helped us set this event. So, blockchain is one of the hottest topics in technology today. It is the underlying technology for bitcoins and other cryptocurrencies and is quickly revolutionizing how business is done. It is an upcoming field in recent times when data holds paramount importance. To break down this extensive topic, we have Mr. Aaron De Miranda Colaço with us, who is a dedicated senior blockchain developer and architect. He currently works as a blockchain architect and is the head of blockchain at Kiwi. Aaron will provide us today with an informative session on blockchain followed by a demo code. Once the event is over, we will send you all the link of the quiz in the chat box to test your knowledge. On answering 80% of the questions correctly, you will be eligible for a certificate. So let's get started and explore the field of blockchain with Aaron. Over to you, Aaron.
Thanks, Ria. So quick question. Can everyone hear me clearly? Am I clear, Ria?
Yes, Aaron, you're clear.
Okay, great. Okay, let me start presenting. Okay. Let me just join the meeting again real quick. I think since this recording, there's a problem. I need to restart my browser. Sorry about that. Okay. Can you see the presentation?
Yes, sir.
Okay, great. So hi, I'm Aaron. I'm a software consultant. I work as a blockchain architect and I'm at the head of blockchain at Kiwi. This is going to be like pretty much an introductory session since all of you are still, most of you rather are still in college. So Blockchain 101. I'm the co-founder of two companies, Decentralized Matter and the Soviet Company. And what we do is mainly blockchain consultancy and dev services. So let's just start off by taking a look at what people much smarter than me have to say about blockchain. So Blythe Masters, who was a former executive at JP Morgan Chase, said blockchain is as significant now as the internet was 25 years ago. So let's take a moment to let that really sink in, right? Like we know how the internet has exploded and how large it is now. And during its infancy, it was this very niche thing that most people were unaware of, people were scared of until, like the dot-com boom. So that's kind of where blockchain is at the moment. However, because of social media, LinkedIn and, marketing, everyone is trying to experiment with it. But yeah, we'll get into that further along into the talk. So In 2016, Gartner had this chart put out. And they placed blockchain at the peak of inflated expectations. So let me quote what this means. It means early publicity produces a number of success stories, often accompanied by scores of failures. Some companies take action, many do not. In 2018, we can see it made its way down from the peak of inflated expectations towards a trough of disillusionment. And this means interest wanes as experiments and implementations fail to deliver. So everyone was raving about blockchain, and many considered it to be a silver bullet. So, and a couple of years later, from 2016 to 2018, all the hype died down. And this was mainly because of failed projects rather, and bad implementations, and also a lot of scams that were done on the blockchain. And this, in a way, gave a bad name to blockchain. Sorry, there's a bit of background noise. Can you mute yourselves? Yeah, and there was, hello. So yeah, there were a lot of scams in the form of ICOs, but this isn't really an inherent problem with the blockchain. For example, there are a lot of scams on the internet. We don't say that the internet is bad and should be banned and that the government should not let you use it. So when similar things happen with blockchain, a lot of people, start trashing it. And so we still have quite a bit of negative publicity around it. So let's see what blockchain actually is. So first of all, it's a decentralized database that stores a registry of assets and transactions across a peer-to-peer network. So think about this. There are thousands of computers all over the world, like the World Wide Web. But here, each computer has exactly the same data. So think of it like a book, right? And each page in the book is one node on the blockchain. And every page has the same entry. So it gives you a security in the sense of you can change one entry on one node or one page, but you can't really change it on all at the same time. So at a very high level, that's how it is. Also, you can compare it to Microsoft Word versus Google Docs. So Google Docs lets multiple people collaborate on it simultaneously instead of exchanging copies with one another. So this essentially creates a decentralized distribution chain that gives everyone access to the same data. So blockchain is a peer-to-peer network. It is a shared ledger and a synchronized state. And there's a set of rules for updating the shared state. So for this talk, let's focus on the Ethereum blockchain, purely because it has the lowest barrier to entry, and I thought it would be a good starting point as an introductory session to blockchain. So let's take a look at some of the properties of a blockchain. It has a shared database. So there's a shared data store among multiple stakeholders. These can be like banks, governments, organizations. It's distributed. So this means it is resilient to faults. It's crash fault tolerant in a way. And there's a replicated setup. It's immutable. So data once entered cannot be changed by any single entity. It is cryptographically secure. It's synchronized, and this is very important. There's a single source of truth. So different people won't have different state and different versions. And it is verifiable. So it's very easy to verify data. It's completely transparent. And another thing, because of all of this, there's a history of change and an audit log. So it's very good for financial institutions or regulated companies to perform end-of-year audits, for example. So to quickly summarize, there's a common database across entities where anybody can read or write reliably. There's no centralized control over database. It runs on several computers controlled by multiple parties. It's resilient to manipulation attacks. Transactions are correctly recorded and in the same order. This is very important, prevents something called as double spend. So transactions once added to the database cannot be modified or deleted. And data is replicated on a large number of nodes. So this doesn't require centralized entities to authenticate and verify data. So let's take a look at the most well-known example using blockchain today. Bitcoin. So I'm sure like everyone has heard of Bitcoin, even if you don't know exactly what it is. So it started with the publication of a paper, Bitcoin, a peer-to-peer electronic cash system by Satoshi Nakamoto. So Bitcoin is built on top of blockchain. It's just an application, kind of like internet, it's kind of like email is built on the internet. It's important to know that Bitcoin is not blockchain. So let's take a look at what makes Bitcoin special. There's no central party, like a bank, controlling it. And whenever you need to send Bitcoins to someone else, you don't have to send it via a third party. It's a direct transfer, and you don't have to pay anyone anything. You have no transaction fees. I mean, you do have transaction fees in a way, but that's a different thing. You do not have to pay a central authority for your payments. There are no conversion charges, no administration charges. And your identity is hidden. So this can have both good and bad implications, like I said before. It's very good, let's say, in a place like North Korea, you want to buy something, you want to pay for certain media, you cannot because of government regulations. You could theoretically do it with Bitcoin, but it's also bad in the sense of like arms smuggling, drug deals, all of that. And there's no double spending, so you can't send the same money to multiple people. And this is possible because of immutability of the ledger that we spoke about, and the consensus algorithm that it uses, which is called proof of work, which we'll come to in a bit. So at a high level, this is how it works. So users initiate transactions using their digital signatures. Users broadcast these transactions to nodes. And these nodes on the blockchain validate this transaction. Once they decide that a transaction is valid, they put it into a block, right? And they broadcast these blocks using gossip protocol over P2P to each other. And the way they come to an agreement about which block is correct and the latest is using a consensus algorithm. For Bitcoin, it's proof of work. And finally, once they come to a conclusion about which block is right, that block is the top of the blockchain, and that's referred to the true state of the block, true state of the blockchain, sorry. And it's kind of like a linked list. So at a very high level, there are two kinds of blockchains. There are public blockchains and there are private blockchains. So for public blockchains, anyone can join these blockchains and anyone can use these blockchains. This would be something like Ethereum, Bitcoin. And then there are private blockchains, which are meant to be used more in an enterprise context. So this is a blockchain which could be set up between certain organizations, political, nation states, etc. And the reason they would do this is because they want to enjoy all the features that blockchain provides, like the audit trail, immutability, all of that, without making data available to the general public or anyone outside the consortium. For example, let's take an example of a large bank. So a bank has different lines of businesses and they need to share data with each other. But obviously they do not want their competitors or the general public to be able to see this data. So they can still use blockchains and they would use a private blockchain. Like I said, let's focus on public blockchains and the Ethereum chain in specific on the Ethereum chain for this talk. So public blockchains, they're open and they have anonymous participation. Anyone can join. I can join the Bitcoin blockchain, the Ethereum blockchain, no problems. It's censorship resistant. There's no single company which is controlling it. There's no single political organization that's controlling it. The way you access public blockchains, at least the vast majority of them, are via tokens. And you pay for each transaction that you do. Let's say you want to send money to someone. I mentioned do not pay a central organization any fees, but you do pay fees for a certain transaction to get executed. We'll take a look at that in a demo later on. So private blockchains would be like I mentioned, Hyperledger Fabric, Quorum by JP Morgan Chase, which is now bought by Consensus, Corda by R3. So they support larger consortiums. They have confidentiality of contracts and transactions, and they support contract life cycles. So these are all requirements, in an enterprise context. So the pillars of blockchain: decentralization, no party controls it; transparency, it's easy to verify authenticity; and immutability, cannot change things in the past. So this is true for all kinds of blockchains. Let's take a look at the various parts that help achieve these pillars. So for Ethereum, we have three basic parts: addresses or accounts, you have the consensus, and you have logic, which is the smart contracts. So addresses, you have two kinds of addresses: externally owned accounts and contract accounts. Externally owned accounts are basically user accounts. They're controlled by a private key. They do not have associated code with them. They have a balance for which you can use, which you use to pay for your transactions and actions on the blockchain, and which you can send people money, or Ether rather. And externally owned accounts can trigger transactions. So I mean, you can read up about public key PKI after this talk and see how private keys and public keys are used for externally owned accounts, because it can get pretty deep, and I don't get into it into this talk. Next, we have contract accounts. So these do not have a private key associated with them. They have associated code. They have an Ether balance, the same as a EOA. And the code execution is triggered by other EOAs or other contracts. And in the Ethereum context, all contract accounts are called smart contracts. And then you have the consensus layer. So one of the most important things to take into consideration when choosing a blockchain platform is its consensus model. So they say a blockchain-based system is only as secure and robust as its consensus model. So consensus is essentially the way all the nodes come to an agreement and make sure there are no malicious actors. So there are three main types of consensus algorithms: proof of work, proof of stake, and delegated proof of stake. And then based on these, there are other spin-offs like proof of authority, delegated proof of authority, proof of elapsed time. And each consensus algorithm has its own pros and cons. So for example, proof of work is very hard to fake, but it's very expensive and slows down the network since there's a lot of computational effort for each block that's added to the blockchain. So all of these are cryptographically secure, and the mathematics behind it is quite complicated. But if you're interested, you can Google it, and it's readily available on the internet, the mathematical formulas. So proof of work. So proof of work is currently used by Bitcoin, Ethereum, and some other chains as well. So the way it works is, in order to add a new block to the blockchain, you have to prove you've done a significant amount of work, or in this case, for the nodes, computational effort. So how do they prove that they've expended a significant amount of computational effort? The way they do that is solve a mathematical puzzle, and solving this mathematical puzzle is very, very resource intensive. So they have special CPUs and GPUs that specialize in solving these kinds of mathematical puzzles, and they consume a high amount of electricity and power. So there were some studies created saying that the amount of power consumed by the Ethereum and Bitcoin blockchains is more than several small countries in the world. So imagine the amount of power that's needed. And that is essentially what makes it so secure. Because me as a single person, if I want to hack or rather change past data on these proof of work blockchains, I need to expend that much energy to solve those many mathematical puzzles again, which is simply not feasible. So because of this, proof of work is very secure, but it's also incredibly expensive, and it's affecting the environment negatively. So that's why, as a whole, the blockchain system is trying to move on to proof of stake. So proof of stake is essentially you stake something, and if you're malicious, if you do something bad, your whatever you stake, which could be like money, which could be tokens, your reputation, whatever, depending on the context, that gets slashed. You get penalized. So you do not have incentive to be malicious, and this is done in real time. So delegated proof of stake is very similar to proof of stake, but you just delegate your vote to someone else that you kind of trust. I found an interesting Twitter thread that explains how life revolves around proof of work. So he says physical beauty is nature's proof of work, right? It's expensive to manufacture and very cheap to verify. For example, a symmetric flower is hard to grow and sustain under influence of rain, wind, and all the environmental factors. But checking the flower symmetry is a very low-cost operation to us, to insects, to all kinds of animals. Professional networking is proof of work too. It's hard getting to know someone, but it's a way of signaling you have enough hustle to say that you can connect with person X. And very relevant, I think, to this talk, since most of you are in college, is a university education is proof of work as well. So why do you go to college, right? Especially now with online courses, you could be learning everything online. But essentially, it's a way of saying that you deferred your entry and went through 4 years of training, rigorous training. You dealt with all your assignments, project work. I mean, I've been there. We hated our files and all of that, right? So it's essentially a way of signaling that you are ready to put in that work. So second component for Ethereum, which would be smart contracts. So this is what Vitalik Buterin, who's the co-founder of Ethereum, says about smart contracts. So most technology now tends to automate workers on the periphery doing menial tasks. So what blockchains do is automate away the center. So as an example, instead of putting the taxi driver out of a job, blockchain puts Uber, Ola out of a job, unless the taxi drivers work with the consumer directly. But for this to happen, we need certain business logic on the blockchain, right? Because right now, Ola, Uber, they run their proprietary business algorithms and their mapping services, the matching between drivers and riders, all of that in their backend. All of this needs to happen with no central party. So the way that's done on the blockchain is via smart contracts. For Ethereum, smart contracts are mostly written in Solidity, which is a Turing complete language. So the benefits of having these smart contracts is transparency. So you can verify the code. So for example, let's say Uber was on the Ethereum blockchain. I could go to the Ethereum blockchain and read their source code, see how they decide prices, see how they match me with the driver, see how the rating system works, all of that. It's completely transparent. It's deterministic and guarantees outcomes. So for example, if I perform suppose I perform an action, I know in advance what the outcome is going to be. And this is very important because if code is not deterministic, it fails consensus and transactions do not work. It has an audit trail to show movement of currency, assets, and this can be done in the form of emitting events from the blockchain, like we'll see later on. And it's very easy to publicly verify data like ownership, voting results, etc. So, however, they do have some disadvantages as well. So they have no confidentiality and there are rogue contracts. So like I said, everything is on the blockchain, everything is public. And as a business, sometimes you do not want that because you do want to have your proprietary solutions and you can't really have that on public blockchains. And that's what kind of gave rise to the whole private blockchains. So contracts can be written with intentional bugs to be later exploited. So for example, let's say I create a smart contract that for a bank. And as a developer or as the founder of that smart contract that's simulating a bank, I could have integrated intentional bugs that would let me steal people's funds. So you need to, so that's why now what's come up in the Ethereum space is smart contracts get audited by certain reputable firms like Consensus that say that a smart contract is safe to use and there's no, malicious activity. Because most people who are not really tech savvy or really who do not have particular domain experience in blockchain, they cannot verify these smart contracts. It's kind of like saying a credit card and debit cards are secure because of the chip, right? So someone has audited that, but we as end users, we do not really audit the chip in our debit cards. And something that's very important is since the blockchain history cannot be edited, so nothing can be done to reverse malicious activity. Suppose your funds are stolen, they're gone. Nothing can be done about it. So when do you use blockchain? So the main times you use blockchain is when you have untrusted parties, when there are multiple writers and stakeholders, when there's a need for a single source of truth across these multiple writers and stakeholders, if you want to avoid middlemen, and when you need auditability. So Jeremy Gardner put out this flowchart a few years ago, and it's really good. So as you can see, most of the times you do not need a blockchain. If you have a single writer or like writers that completely trust each other, you probably don't need a blockchain, right? You could just go with a centralized database or even a distributed database. But if you do need a blockchain, there are three options. You can have a consortium or hybrid blockchain, or totally private blockchain, or a public blockchain. And when blockchain like initially started out, everyone just wanted to play with blockchain, right? In fact, I remember there was a publicly traded company that included blockchain in their name, and their stock prices doubled in value overnight, literally overnight. So everyone jumped onto the blockchain hype train, and that's why they were at the peak of inflated expectations and everything. As they realized that blockchain was not a silver bullet, and most of them did not need blockchain, like the hype died down since all these projects started crashing. Right. So let's look at some use cases. So I think let's take a moment here to pause, and from the audience, if there are any questions so far. Anyone? Any questions? No? Everything clear? Can anyone think of any use cases that you would like to discuss? Okay, everyone's awfully silent. Guess we can resume. So good examples of blockchain, good use cases, according to me at least, are asset registry. It could be something like land records, certifications, let's say your university certifications. So that's very easy to verify. So what MIT, the Massachusetts Institute of Technology, has started doing is issuing certifications on the blockchain. So it's very easy for anyone to verify student certificates. Supply chain and distribution channels are one of the best use cases for blockchain, simply because they have so many different parties that all have different interests and different technology backends, and everything is so fragmented that having this single source of truth with a proper audit trail is very important. I met someone who worked with the British, or rather with the UK government, on a supply chain use case for their armed forces. And what they found, they had certain aircraft carriers or something like that, and there was a faulty component. And it took them 6 months to track down the original supplier, and they spent millions of pounds doing this. When they modeled this entire thing on blockchain, they realized that the cost was, like zero. There was no cost because there's just binary cost when you're running a blockchain, 0 or 1. There was no additional cost. And tracking down the initial supplier was like a matter of like a few seconds. So supply chain, again, is a brilliant, it saves time, money, resources. Sharing health records is another good use case. So especially with organizations like the NHS, you have different hospitals, again, with very different systems. There's no standard. When people move from one location to another, from one postcode to another, the primary health center changes. Records need to be moved from one place to another. And there's no easy way of doing it. It's operationally intensive. It's very manual. So sharing health records could be done very easily on the blockchain. Like moving your health data from one provider to another provider, revoking access to your previous provider. I mean, obviously, they do not need to see your health records anymore if they're not treating you anymore. And what blockchain is being used for quite a lot is also fintech, especially Hyperledger Fabric and R3 Skoda. They use it for netting, for settling ledger balances across various national banks, for example. There are also other use cases. For example, someone created a gym application that made sure that you're working out every day. And initially you put in some money to kind of incentivize yourself to work out every day. And if you did not work out on a particular day, it would track it via wearables. So this could be a Fitbit, your Apple Watch, or whatever. And if you did not work out, it would penalize you. I guess that's kind of like a good use case, especially during the lockdown. So the hype cycle for blockchain in 2018 from Gartner. So we can see that blockchain reward models, initial coin offerings were kind of like at the peak of inflated expectations. And those initial coin offerings, which I mentioned earlier, the ICOs, those were very scammy. And that's one of the reasons the interest in blockchain died down, because there were so many scams in that. Blockchain in supply chain was just beginning to take off in 2018. And now they found out that it's one of the best use cases. So cryptocurrencies have been the best known use case for blockchain, right? And Bitcoin is like known proof of that. Like Bitcoin is so well known that people who haven't heard about blockchain at all, for example, my grandmother has no clue what blockchain is, but she's heard about Bitcoin because it's on the paper and all of that. Yeah. So hype cycle for blockchain businesses in 2019. This is how it progressed. As you can see, the blockchain and rewards and loyalty moved further down the curve. Blockchain banking and investment services also moved further down the curve. And the ICOs were the trough disillusionment because of all the scams. And cryptocurrencies as well were given a very bad reputation because of that. So one of the best use cases for blockchain in the retail is the retail space. So in retail, blockchain is being considered for track and trace services, for counterfeit prevention, for inventory management and auditing. So any of these could be used to improve product quality and food safety. So IBM, for example, has a blockchain to track the food supply chain, to figure out where your fish originated, when it was, when a fish was farmed or when it was got from the ocean, what's the route that it took, how long was it stored, in what kind of temperatures was it stored, is it likely to give you food poisoning, and all of that stuff. So all of these examples have value, but the real impact of the retail industry, we've still not seen it, just because there's not enough widespread usage yet. Once it has been combined with Internet of Things, IoT, and artificial intelligence, so blockchain has the potential to change the retail business models forever. You always know that the food that you're having is the freshest. You can track the entire distribution. You can see exactly where your food has been, how it's been stored. And this is without someone entering it. So since I mentioned, like, it'll have like IoT integrated, you always know what its state was. And this impacts both the data and monetary flows, right? Because it removes any middlemen. So Gartner says blockchain has the potential to transform business models across all industries. But these opportunities demand that enterprises adopt complete blockchain ecosystems. Without tokenization and decentralization, most industries will not see real business value. And that's critical, right? Because without tokenization, what's the point? Like you cannot accurately tokenize whatever you're trying to do on the blockchain, be it like food, parts for your car, like it won't work. And it has to be decentralized. If there's a single entity that's controlling it, like what's the point? So for example, in the food supply chain example, if there's just like Walmart and they enter like all the data they enter all the data manually that you see, it has no benefit. You have no way of, like, why would you trust them? It's as good as not using a blockchain. So that's why if you had like IoT devices that periodically push data, that's much more trustworthy. Or for example, different suppliers pushing this data themselves versus just Walmart. Right, so the advantages: reconciliation. So between entities is much easier due to shared data and deterministic results, like I spoke about earlier. This provenance. So for pieces of art, rare stones, this is critical. How do you verify your certificates? How do you verify that your diamond was actually minted from a particular mine and it's not fake? This is very easy using blockchain. There's integrity. So it's tamper-proof data because it records hashes on the blockchain, which are very easy to verify. Ownership is very easy. And like I said, audit trail. There's a chronological record and evidence of the sequence of activities. So you know exactly what happened when and in what order. Having said that, there are also significant problems in the blockchain space, and these are basically the lack of standards. Blockchain is still a very new tech. It's evolving very rapidly. And because of this, there are a lack of clear standards. There's a performance problem. So this is the most widely known problem with blockchain, right? So they say like MasterCard, Visa can support between 40 and 60,000 transactions per second, whereas the Ethereum blockchain can support maybe a few hundred tops. So there's a massive gap in the performance that's needed by the industry and public blockchains. Private blockchains as well, they are much more performant than public blockchains. That's because they do not use proof of work as a consensus algorithm. They use like proof of stake or proof of authority, but still they're nowhere close to what centralized systems have at the moment. Another problem is personal data poisoning the blockchain. So this makes like most public blockchains non-compliant with government and privacy laws. So because it's immutable, you cannot remove past data that was anchored to the blockchain. So this could be like, payments to like human traffickers, to drug cartels, like data regarding that. So since it cannot be removed from the blockchain, audited organizations and certain government bodies as well, they cannot have this in their data centers for obvious reasons. They say blockchain will transform the economy, right? So how will this happen? There's a very good TED talk about it. You could just Google this title, How the Blockchain Will Radically Transform the Economy, and you could watch that. I think it's about 11 minutes long. And I mean, I think it's from 2016, but it's still a good video. So blockchain will remove uncertainty and trust. And smart contracts execute in a deterministic manner without the need for this trusted middleman, right? So let's take a look at one example. So smart contract for farmer insurance. So let's say farmers in India, I mean, there's always a plight for the farmers in India. So let's say they register with a smart contract, right? This could be via the mobile app and all of that. So blockchain in general at the moment has very bad UX, and it's purely because the tech is so new. We do not have very good flows around it, but yeah, that will change. So let's say farmers register with a smart contract, right? And they pay like certain amount of insurance or whatever. Whenever there is bad weather conditions like floods, maybe like a storm, a cyclone, a hurricane, whatever, this is detected. I mean, it's easy to verify that there was that there were bad weather conditions, and a smart contract automatically pays out these farmers. So this is decentralized. There's no person that the farmers need to go to and apply for the insurance. They do not need to prove that there was actually bad conditions, bad weather conditions. Uh, and there's no need to trust someone. There's no need to bribe someone. There's literally no middleman. The blockchain detects that there were bad weather conditions, and the blockchain automatically pays out all of everyone who's registered with it. And it's much lower cost since there are no salaries to be paid, no operational expenditures. The insurance rates will also decrease. The premiums you need to pay will drop significantly. It can also be used, for example, for your vehicle insurance. So when you buy a car, you register with a certain smart contract. And when your cars are getting, smarter day by day, you have Teslas, which are self-driving cars, Mercedes, BMWs are coming up with their self-driving and highly connected cars as well. So all of them already have like a bunch of sensors. For example, Tesla starts recording a video, a 360-degree video whenever someone bumps your car, comes too close to your car when it's parked and you're away. So that when you come back to your car, it will show you who's bumped into your car, who scratched your car, all of that. And that's already there. So now, let's say these IoT sensors, when they detect a problem like an accident, intentional, maybe someone scratching your car, maybe someone banging into your car intentionally or accidentally, whatever. Once they detect a problem like this, they send data to the smart contract, and a smart contract automatically pays out this insurance amount to you or to whoever it is. Like, for example, let's say your service station, your dealer, whoever is going to be fixing your car for that amount of damage, they can automatically pay this out. You do not have to do anything. It's all taken care of. And self-driving cars, you go home, you drive your car home, your car drives itself to the mechanic, it gets repaired, it comes back. That's a possibility. Yep, and it's also much lower cost again, because there's much less operational cost, because once a smart contract has been written and deployed, you do not need someone to constantly check in on it. Let's take a quick demo. So any questions? Nope. So either I'm doing a good job at explaining or nobody's following at all. Wait, there are some chats. Oh, I'm sorry, there are chats over here. Is everyone muted? Y'all can just speak if y'all want. So Kevin says, with the advent of quantum computing, can blockchain still be secure? So no. So with quantum computing, the mathematical puzzles that are involved in proof of work are no longer as secure as they used to be. And that is why we are moving to proof of stake. So proof of stake is secure against quantum computing, because essentially you are staking some sort of funds, like maybe Ether, maybe Bitcoin, maybe a stable coin, USDT or something like that. And if you're malicious, what happens is your stake gets slashed. Explain a blockchain that can be used for a small business. Adriel, you really have to tell me what a small business is. If you're talking a small mom and pop shop, you definitely do not need a blockchain. Like I said, unless you have multiple parties, reconciliation problems, there's no point using a blockchain. Could you perhaps mute yourself, and maybe I'd really like this to be a more interactive session. Ria, can they unmute themselves, or have you muted everyone?
They can unmute themselves.
Okay, so
they can unmute themselves.
Okay. So Kevin, do you want to unmute yourself, or did that answer your question, Adriel?
Yeah, that answers my question. Thank you, Aaron.
Yeah, sure. Adriel, I hope that answered your question as well. Sahil, so how miners mine a block? So like I mentioned, everyone gets, all the blockchain nodes get a transaction, and they try and solve a mathematical, at least for proof of work, they try and solve a complex mathematical puzzle. So whoever solves this mathematical puzzle first creates a block and publishes it to the blockchain. Everyone else verifies that this block is correct. If it is correct, whoever created this block by solving the mathematical puzzle gets rewarded. So in Bitcoins, it could be you get rewarded N number of Bitcoins. For Ethereum, you get rewarded N number of Ethers. For proof of stake, it will be similar. So, but the way it works is a little bit different in the sense of you do not have to try and solve a mathematical puzzle as quickly as possible. The way the algorithm works is you stake, let's say I stake 100 ether and you stake 50 ether. So maybe that means that I mint 50% more blocks than you do. So we're each given a chance to mint blocks at a certain timestamp. So let's say I create a block, I broadcast it. Everyone else validates that block. If it's correct, I get rewarded. My stake increases. If I was malicious, my stake gets slashed. And so that's how there's no incentive for me to be malicious. Can a blockchain keep an organizational data secure from smart computer hackers? Yes. So when you say secure, there are two things, right? So one could be, do you want to keep it secure in the sense you do not want them to read it? In that way, then you would not use a public blockchain. So for example, let's say a financial institution is not really going to use a public blockchain. Like I mentioned, let's say Barclays Bank, for example, they're not going to be using up Ethereum because they do not want their competitors or the balance of various users, etc. They will be using a private system. So the read privacy is there by default, and against the hackers thing, the way Bitcoin works is as long as the majority of your nodes have the right data, so as long as 51% of your nodes have the right data, the blockchain is said to be like non-corrupt. And this is actually a pretty good statistic because let's say for the Bitcoin network, there are thousands of nodes, right, all over the world distributed geographically. So me getting access to all of these, let's say there are 10,000 nodes, me hacking 10,000 nodes at the same point of time is very difficult, purely because each of them are very well built. Most of them are pretty well secure behind firewalls and all of that. And even if they're not, the underlying technology is pretty tamper-proof. And even if I do get access to it, like how am I going to solve like so many complex mathematical puzzles before the people who run the nodes detect that they're being hacked? So yeah, it is overall very secure. Shubham says, with the value of Bitcoin rising over time, people are looking to invest in it and it is not spent like other currencies. So what is your view on people using it as a regular currency for transactions? Or what will lead to mainstream usage of cryptocurrencies, especially since people are looking at it as a safe investment? Okay, so it's very interesting. With the global pandemic and the lockdowns and everything, the value of Bitcoin started increasing. And people thought that it's a good value store because currencies, right? There are more dollars being minted every day. There are more Indian rupees being minted every day. It's going to lead to crazy amounts of inflation because currencies that the governments are printing, they just print more and more currency. Whereas with Ethereum and Bitcoin, they are capped. Bitcoin especially is capped. Beyond a certain time, there's going to be no more Bitcoins that are in the world. And that means all the Bitcoins that are already there will start increasing in value. So again, it's going to be like, a while before that happens. It's increasing gradually now, but there will come a point when it will increase drastically. Again, no investment advice at all. And always invest only what you're willing to lose. Because there have been several crashes in the cryptocurrency space. So yeah, it's been increasing the value of blockchain, and people are beginning to, especially mainstream users, are starting to get into it and just put in money. And even if they get like a 2% interest rate or 3% interest rate, they still think it's very good. If the valuation increases by that much. Yep. Any other questions? Again, please feel free to unmute yourselves. Nope. Okay, so let's present again. Yep, there we go. So let's take a quick demo. So I mentioned that in Ethereum, we write smart contracts using Solidity. Most of the smart contracts are written in Solidity. And this is a very, very basic example of a smart contract in Solidity. So what this does is it lets a person deploy a smart contract. So for example, let's think of this as a bank account contract, straightforward. I have a contract, like, I can pay out anyone from my bank account via UPI, via NEFT, via RTGS or whatever. So let's say this is a simulated bank account and it has a certain number of tokens. These tokens can be anything like dollars, rupees, euros, pounds, ethers, USDT, doesn't matter. So we have owner, which is I'm the owner of my bank account, naturally. I have a certain number of credits, right? So yeah. So the type of credits would be UN 256. This is to prevent overflows. It's a very large number. When I deploy it, I set myself as the owner. And for an example, normally, like, I would fund it with actual money. When I deploy the smart contract, I would send it Ether and it would fund itself with that. But for the case of simplicity over here, I can decide how much I want to fund it. I manually enter how much I'm funding it with. I could say 100,000, whatever. And if I want, I can withdraw tokens to myself to another address that I own. So for example, I could transfer it from bank account A to bank account B, or I can transfer it to someone else, right? So to any one of you, for example. And at the moment, this is all simulated. There's no actual transfer happening, but let's assume that that was integrated. So the way you could do that, actually the most straightforward way at the moment, is adding the ERC20 standard. So this is the standard used by a majority of the tokens on the Ethereum blockchain at the moment. So what this does is it makes sure that only the owner, only I over here can call the function. So only I should be able to withdraw money from my account. If you want to give this permission to someone else, let's say a spouse, or let's say you want to add Netflix or someone, you could create like your own smart contract, add Netflix as a trusted party over there, and allow them to withdraw a certain amount per month for your subscription or whatever. You can also do that. But for this contract, there's only one person or one address that's allowed to withdraw, and that's the owner, which was set at the time we deployed it. If that's fine, it goes ahead, otherwise it fails. Of course, it naturally requires that the amount I'm trying to withdraw is less than the amount available. It emits a withdraw event. So I said we have these events on the blockchain. So it emits this. So in the future, let's say, like, at the end of the year, I want to go through all my transactions. Like, I start listening on the blockchain and I just listen to all the withdraw events. And then conversely, if I wanted to deposit money to the smart contract, I could have like a deposit function that emits a deposit event. So I listen to all my withdraw events, all my deposit events for free. I don't need to pay my bank for a statement or anything. To generate like a 10-year statement, I don't need to pay anyone. I just traverse the blockchain and it generates my CSV, my Excel, whatever, in whichever format you want it. And then, of course, it debits you for the amount that you're withdrawing. On top over here, we have the version of Solidity that we're using. Since most of you are from an engineering background, let's say if you're using Java, you would use a particular version of Java, your JDK. Same with any programming language, really, Node.js, Elixir, whatever. So yeah, so here we are using 0.6.0. This is the name of the contract. So, and if taking a step back, if any of you want to try it, just type remix.ethereum.org and you will get this online compiler to basically try smart contracts, play around with it and all of that. And this is how it looks when you start it out. So you have Solidity, which is very easy to get started with, a lot like JavaScript. So the barrier of entry is very low. And then you have another smart contract language, which is Viper, which maybe don't start with that right now. So yeah, you have some basic smart contracts that come with it. I mean, when you open it, these are always there. Storage, owner, ballot for voting. If you want to do TDD, you have like your test cases already started out. And so basically, then you have Solidity test, which is what I wrote. Yes. So what we'll do is let's compile this contract. So you can choose your compiler version, your language version, all of that. Um, compile it. It compiles successfully. Very good. And you can choose where to deploy it. So right now, let's run it in a simulated environment. Because when you run it on the actual blockchain, I mentioned that miners solve a computational puzzle and they get rewarded for if their block that they submitted was validated and there was no malicious activity and they were the first to solve the puzzle, blah blah blah. All of that, they get rewarded. And how do they get rewarded? This reward is basically two things. One is like they get rewarded like a normal amount. Plus, what they also get rewarded is every transaction in that block has paid a certain amount of ether. So the way this ether, or rather this gas, so the units that I use over here, since a very low amount is gas. We do not pay like a full ether, which would be like very high. We pay gas. Gas is, think of it like this. You need to run your car. How do you run your car? You put in fuel, you put in gas. That gas costs money. So the gas is the fuel for Ethereum, just like gas is fuel for most vehicles out here. So you pay with gas. So you can put in the amount of gas that you're willing to spend, the value of each gas. So where is that? Okay, this is the basic view, so that's not shown. So you put in the gas limit, the maximum amount of gas that you're willing to spend, and you also put in normally something called the gas value. So each gas unit, like here, that let's say I'm sending 10 gas units. Let's say I'm sending 10, my gas limit is 10. I can choose how much I'm willing to pay for each unit of gas. So for example, for each liter of fuel, how much are we willing to pay? Like 50 bucks, 100 bucks, whatever. This value is how much you are sending with your transaction. This is separate from the gas. This is how much ether you're sending. Kind of think of it like a tip to just really keep things simple at the moment. It's not the cost for your transaction, but it's how much you're seeding the contract that you're deploying with. So I mentioned when we were doing this, that I am seeding it manually with like passing in a value. Alternatively, what I could do is I could do message.value. And then this would take in the amount that I have sent it. So for example, if I've sent it 100 way, it would take in 100 way. If I've sent it 200 way, it would take in 200 way. Yeah, this is the contract I want to deploy, and let's deploy it. So let's deploy this contract for myself with let's say 100 credits, right? And I'm deploying it to the JavaScript VM. I could also deploy it to the Ethereum mainnet, which would cost me like actual money. So I'm not going to do that. I could deploy it, and then in engineering generally, we have like a production environment and a dev or testing environment, QA environments, all of that. So the same thing with so for Ethereum, you have the Ethereum mainnet, which is over here. So for example, this is a block, right? So etherscan.io, the block number this, has 268 transactions. It was mined by this miner. So this miner mined that block. The block reward was 3.5 ether. So because they solved a computational puzzle and mined this block, they got this many ether. The mathematical difficulty was so much. The total difficulty of the blockchain until now is so much. The size of the block, the gas used for this particular block, and of course, this extra data, hashes, all of that. Let's forget about that. Okay, so let's see. This block had 268 transactions. So these are all the transactions that were in the blockchain. So let's take a look at this transaction. Or let's take a look at this transaction actually. So if we take a look at this third transaction, it is from this account to Binance, which is kind of like a trading platform. So yeah, this is the transaction hash. This is the block that it was minted in. This is how long ago it was, the address from and to, and the value that was sent with the thing. So this would be like the value that they've sent with the transaction, which was 5.2 ether. So they probably traded worth $2,000 worth of something. And they have paid a transaction fee of like 88 cents. So this would be on the mainnet. So this is the Ethereum mainnet, and this is the fee that they paid for that transaction. So since we do not want to do that and we just want to try things out, over here, you would choose a JavaScript VM, which would just run it into a virtual environment in your browser. So again, let's deploy a contract with 100 tokens. You can see it is successful. So here is the transaction. So the status is mine. This is the transaction hash. The contract address that I just deployed, this is the new contract that I created. This is the address I sent it from. This is the gas I sent, the gas usage, the execution cost, blah, 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 all of that. Okay, so this is the contract address. Here, I've deployed it. And this is the address I've deployed it from. My balance was 100. It's dropped to 99 point whatever. And the ending is 6D629. And if you see the owner, you can see that that's the owner, the address that deployed it, because the message that sender was set as the owner. If you see the credits, there are 100 credits. Now, let me switch the address. So this is the address I deployed it from, the second one. Let me switch to the first address. So if the first address tries to read the credits, it can do it, no problem. If it tries to read the owner, it can do it, no problem. This is because public data. If I wanted, I could set it as private. So let's say I want to withdraw tokens to this address, which is not the owner. And I want to withdraw 10 tokens, right? So let's say if I try to withdraw, it throws an error. What? No. Okay, let's say I want to withdraw 10 tokens. Why is this failing? Address type value. Oh, 1 second, let me deploy it again. Compile. Yep, that's there. Let's say I want to use another address to deploy. Okay, right. So there was a problem with the VM. So now what I've done again is I've repeated the same steps and I'm using a different address from the owner. So I'm using 6. Now the owner has changed. The owner is F7B. I'm using 629 to try and withdraw funds. And when I say withdraw, it throws an exception saying that only owner can call this function. So it detects that the owner is not calling the function and it's not authenticated. So now let me try and use the owner to call the function. If I call the owner, and I mean, the balance remained unchanged because the transaction failed. If I use the owner, the transaction succeeds, right? So now if I check the credits, what is going wrong? Why withdrew to myself? Right, so the transaction succeeded over here. And I withdrew 100 tokens. So the balance should be 0. Yeah, it is 0. This was the transaction. This is the transaction hash, which is a unique identifier from the owner to the withdraw function. The transaction hash, the inputs that I sent, this was the decoded output. And I sent no additional money with it. So yeah, sorry that demo didn't go as smoothly as I hoped it would. Can I? Oh, I'm already presenting. Yep, so that was a really quick demo. And very important to note, I think, is like blockchain is a journey, it's not a destination, right? it's a very new technology. There are lots of things changing every day. From zero knowledge proofs, new types of zero knowledge proofs, some ZK Starks to ZK Snarks coming out, to new use cases and architectures that come out to help you have like either fully decentralized solutions or integrating blockchains into an enterprise for like only the data layer. A lot of things are lots of things are changing. And I think this is a very good time to get into blockchain, purely because we're at a point where, at least in the early days of blockchain, the barrier to entry was significantly higher because it was hard to come across resources, training material just for a general idea about blockchain, and dev resources, tooling, all of that. And right now, everything, it's easier than ever to get into blockchain. The industry is like really picking up. Especially despite COVID, like I said, like Bitcoin is booming, Ethereum is booming. Lots of projects are coming out because the trust in governments, or rather the trust in centralized parties, has fallen. People are pushing more and more for decentralized solutions, and it's a good time to get into blockchain. So yes, any questions? I like puppies. Please unmute yourselves. And if you have any questions, or if there's anything more you would like me to cover, I kept some time because I was hoping to make it more interactive. Ria, is there anything else that you would like me to speak about?
If you think that there's anything else which we're missing out, then you could just add it if you feel like.
Okay, so since we focused on Ethereum, let me tell you like the easiest way to like get started with Ethereum. So Ethereum uses a Solidity. So let me send a link in the comment chat. This is a very good tutorial to get up and running with Solidity, which is the language that the smart contracts are written on. Very good. Just follow along over here. You can start with the basics. So yeah, you can start with the basics over here and just keep on clicking next. And to try everything, you go to remix.ethereum.org. And again, you try everything here. Make sure you have the JavaScript VM enabled. You can simulate different addresses over here, all of that. You can change your amounts. Brilliant tool to learn. Once you start learning this and you want to get deeper into it, like write test cases, do TDD or BDD, have CI/CD pipelines, all of that, then I would suggest you go to trufflesuite.com. And what trufflesuite.com has is they have Truffle, which is basically build tooling, dev tooling. They have Ganache, which is a blockchain simulator. It will not try and solve these complex mathematical puzzles, etc. It will just simulate the blockchain as a single local node on your machine without connecting to the Ethereum mainnet. And it will allow you to prototype things very quickly. So let's say you want to simulate a bank or multiple parties. You just keep sending transactions. If the smart contract logic is successful, it will simulate these transactions on your local machine and tell you whether it's right or wrong, whether it went through or not. When you're automating things, it is much better to use this compared to Remix, because you don't want to keep on clicking things manually. You can just have like your code running, maybe in a for loop, you want to simulate something or whatever. It has Drizzle, which would be basically a front end if you want like your React Native stuff. I haven't personally used it, so I'm not too sure how it works. They have their own documentation as well. So for each of their tools over here, they also support like Cord, Tezos, Fabric, Quorum. But yeah, if you're really getting started with blockchain, especially if you're still in college, I strongly suggest you get started with Ethereum first, because it will really teach you the basics. And otherwise, you need to learn all kinds of other things, how to manage security certificates and authorities and your chains and all of that for Pledge of Fabric, which might not be very straightforward if you've not covered all of these topics yet. Yeah, that's Truffle Suite, Solidity. What else? Yes, I mentioned Etherscan. So Etherscan lets you see. So Etherscan basically indexes the public blockchain. For example, there are two ways you can read data from the blockchain. Either you run your own node downloads the entire blockchain, which is at the moment massive, right? Can be like a TB, 2 TB, depending on whether you download a compressed version or not. Sorry about that. So Etherscan lets you read the public blockchain. They have like a UI and they index the entire blockchain. You can see all the blocks, you can see all the transactions, all of that. You can filter based on addresses, tokens. So for example, let's try filtering by a token. So Storj is a popular token that is for file storage, decentralized file storage, and they have a token on the Ethereum blockchain. So for example, I can see all the transactions with the Storj contract. So like I said, it's very transparent. I can see who's doing what. I cannot see the data because it's hashed, encrypted, whatever scheme you choose, depending on why you want to use it, maybe for anchoring data hashes. But at the end of the year, let's say they want to prove to their auditor, which could be like Deloitte, KPMG, whoever, that they have actually done something, that they've not manipulated data. They could have anchored a hash onto the blockchain. And when they reference the original data, it's easy to prove that it's not been tampered with. This is the Ethereum mainnet, which is expensive, all of that. Then once normally you would try things like with a truffle tooling, right? With a truffle environment rather. After that, if you want to try it in a system closer to a production Ethereum mainnet, you could run it on Ropsten. So Ropsten is basically Ethereum testnet. That's what it's called. There are various testnets: Ropsten, Rinkeby, all of them. Ropsten uses proof of work. Rinkeby uses something else. So you can use Ropsten to simulate things in a environment that more closely mimics the Ethereum mainnet. So this could be like, the time each transaction would take to get minted. So for example, in Remix, it's instant. In Truffle, it's instant because there's no complex mathematical puzzle. On the Ethereum mainnet, it takes maybe 10 seconds, 15 seconds, depending on how many transactions are coming into all the miners and who's paying what amount. So yeah, you learn about all of this in the docs and while using Truffle. Ropsten will let you simulate the Ethereum mainnet very closely. Again, it has like, all the blocks. You can see all of that, and you can see who the miner is. You can see all the transactions. It's exactly like the Ethereum mainnet. But the difference is you do not have to use actual Ether. So you don't have to pay with actual rupees, dollar. So you don't have to buy Ether upfront. So for the Ethereum mainnet, you need to have Ether to make transfers. And you can either buy this on popular exchanges like Binance, CEX, or Kraken or something else. Or, like you buy it P2P. If you know someone, you send them money and they send you the tokens. And you use that to pay for your transactions. But on Ropsten, you can generate an Ethereum address and then you do and then you have a faucet, which is over here. What they do is they send you fake money. So all you've got to do is you've got to generate an Ethereum address. You enter your address over here. So for example, let's say this address this address doesn't have a lot of money. So this is a fake address on Ropsten. So let me try and send them some money, some Ether rather. Yep, see, test ETH sent, it's gone. So test ETH had been sent to that address. So they had 61, whatever, something. Yeah, I mean, it'll take some time to get minted. But yeah, more money will be credited to them. And that's how you create your own Ethereum address. You enter it over here. You say, send me test Ether, and they will send you essentially fake money, which you can use to like simulate all your transactions and all of that. It will very closely mimic the production environment. What else? Ether. So Consensus is one of the reputable firms in the Ethereum space. You can explore their solutions, what they provide. If they partner with like some of the world's leading organizations, like they said, Hitachi, EY, Microsoft, AWS, all of that. They have solutions for different things like asset management, capital markets, DeFi, payments. Once you start learning about blockchain, once you want to get deeper and deeper, you can check out their case studies and their publications to see how they address certain business cases. Let's say privacy having privacy on Ethereum using zero knowledge proofs and all of that. But I mean, that's still pretty advanced. Yep, I can't really think of anything else at the moment. Oh, sorry, there's some questions here. Can we use Python in Ethereum IDE? So I think, no, you can't really use Python. What you can do, so when I mentioned using Truffle, yeah, good question. When I mentioned using Truffle, let me share my screen again. When I mentioned using Truffle, it simulates the blockchain on your local machine, and there are various ways you can interact with it. I mean, if you're in first or second year of college, you're still probably using just C and C++. Maybe you're using Python, Java in later years. JavaScript, maybe everyone's using Node.js. So in the Ethereum space, at least, the easiest way, the most robust way to interact with the Ethereum blockchain is using Node.js and JavaScript. And I know this is a big no-no for like financial institutions, regulated bodies. But the reason it's so easy to use this is because it has the largest developer base. Bug fixes are very quick. Stack Overflow and resources are most easily available. You can use Python using Web3 Pi, I think. Yes. So if you're using JavaScript, if you're using Python to communicate with the blockchain, you would use Web3 Pi. This is for Adriel. If you're using JavaScript and Node.js to communicate with the blockchain, you would use web3js.com. I mean, use web3js. And the documents on web3js, read the docs. I just sent the link in the chat. And of course, then you have Web3 Java. Then you have Web3J, which is a client for the Web3 Java. For those of you who like the JVM and want to use Java-based, JVM-based languages. And again, there are implementations and SDKs in possibly every language out there, like from maybe not C and C++, but from like Clojure and Elixir and Erlang to like PHP even. But yeah, by far the most robust is and easiest to get started with, I would say, is the Web3JS library. But yeah, Python won't be like that much harder if you're already comfortable with it. Vishal says, what is the day-to-day work of a blockchain developer like? Want you to know exactly the kind of work that they exactly do. So I mean, it really depends. If you're working, so for example, let's say you're working at Consensus, they have blockchain developers. What they do is like build POCs. So let's say they have like interest coming in from a large client to build a particular use case on the blockchain. They would do that. So it's kind of like asking what the work of a backend developer is. There's no right answer there. It really varies. But you could be writing smart contracts if you're working on Ethereum. You could be writing like the backend systems to communicate with the with the blockchain. You still need to know some blockchain knowledge. You still need to have like blockchain and domain expertise over there uh, to know about best practices, flows, all of that. Or you could be building what are known as dApps. So what dApps are decentralized applications. So for example, let's say right now we use Zomato, Uber, all of that. When we make a request via the app, it goes to the Uber, Ola backend services and their servers, and they send us a response based on proprietary business logic that runs in the background. What a dApp or decentralized application does is, when you have an application and you make a request, it directly sends that to the blockchain, to a blockchain node. Now, this could be a node that's being run on your behalf by someone else, a node that's running at your home via static IP. It could be anything, like forget about the architecture behind it. But that's what a dApp does. It does not go to any centralized party. It goes directly to a blockchain, and you have signed it on your device. So there's no middleman that could have changed your request because they do not have your private key. So again, that's also the work of a blockchain developer. So these are all area things that blockchain developers can do. And of course, then there's also like business consultancy, like, advising people about changes, right? Okay. So I hope you guys could hear me. So yeah, dApp developers are also blockchain developers, and they build these front-end applications. So there you would need to know like blockchain. You would need to have like domain knowledge about blockchain, as well as like whatever front-end tech you're using, maybe like Angular, React Native, or whatever. Yep, that. What else? Yes. So if you're running your own nodes, what you need is like a good internet connection, a lot of disk space. And if there are two ways to run the node. Either you join as a miner, in which case you say, yes, I also want to solve these complex mathematical puzzles or whatever, and get rewarded by submitting a block, in which case you need a lot of computational power. So you could buy specialized processors and GPUs for this. Or you could join it as like a light node. What that basically means is you only get transactions and you send transactions. You do not try and solve mathematical puzzles for rewards. And the reason you would want to do this, let's say, for example, like I said, I have a dApp, right? Like, let's say I'm a small company, and let's say I'm a small insurance provider. And I really want to focus on like my domain, insurance and all of that. I do not want to get into like mining and maintaining nodes and like CPU heating and all of that stuff. So what I can do is like I can run like a light node. All of the transactions that I do, like paying out customers, like asking for insurance premiums, I send that to my light node. My light node broadcasts that to the rest of the network, and the smart contracts by the other users or whatever pay it, and I get notified via my local node. So yeah. And the way you would run a light client is by using the Ethereum Light Client protocol. You can read about it here. And if you really want to get into like how the internal data structure of a blockchain is, you can read about Merkle trees and how they're constructed. But yeah, if you really want to get up and running with blockchain as quickly as possible, I would say go through the first link which I sent, which is Solidity. Read the docs, and just start trying things over there, because you'll start getting into code like immediately. Hey, Lurian. Hi, Aaron. What resources would you recommend to say master students in finance and banking about blockchain? A bridge between the technical and basic. We currently run student competitions around this. Okay, let me open that real quick. Right. Okay. So for finance and banking, so I'm currently working on something, and the top contenders really, if so, with finance and banking, what you really want, so you can have either decentralized finance, or you can have like, like regular finance with the benefits of blockchain, helping these multiple banks and stakeholders, maybe your central government regulatory authority, and overseeing committee, also being part of the network. So let's say if you're going with DeFi, then the best thing to do is, again, if you're going to start like coding right off the bat and all, then I would say like go through the Solidity, read the docs first, and then follow the same progression, and then read about consensuses, use cases with the DeFi. They have like very good use cases with DeFi, and there's also and I think this one and this one. So for example, decentralized finance, they have good code bases, good architecture. I mean, the things about insurance and all of that, but the architecture and all will very closely mimic general decentralized finance. If you're talking about a more traditional kind of finance system with like, your government regulatory bodies and all of that, I would say either look at Hyperledger Fabric or R3 Scoda. Hyperledger Fabric is kind of like a general purpose blockchain by IBM, and it lets you have multiple organizations with inter-organizational privacy. So for example, let's say you have two banks and these two banks transact. They can choose what data to share with each other while leaving out a third bank and all of that. It allows you to model very complex relationships. And then there's also R3 Scoda, which is a brilliant, and which is brilliant for the financial industry. In fact, it's purpose built for that. Let me send this over here. So I'm currently working with R3 Corda. So R3 Corda has been used by the Singapore government as well, and it's been also being used by HMRL, Her Majesty's Land Registry in the UK. And it's purpose built for tokenization, especially for the financial industry. It lets you have transactional level privacy across different organizations, which could be like banks, which could be like banks, or like, oversee like a RBI or whichever your national bank is, other regulatory bodies and all of that. So yeah, for the more traditional route, I would say like definitely take a look at R3 Skoda. It's by far the best because it just works out of the box and gives you a lot of the features that you would have to like, build yourself if you went with Hyperledger Fabric. But yeah, for DeFi, generally the best thing is Ethereum. Sorry, that was kind of all over the place, but I hope you got the gist of it. Any other questions? If not, I would say over to you, Ria, and maybe you can talk about whatever quiz.
Thank you so much, Aaron, for joining us today. I mean, I'm pretty sure that everybody had a really insightful session and you spoke very well, and we were happy to have you. And yeah, Sanjit will go on to tell about the quiz.
Thanks a lot for having me, Ria, and it was a pleasure. And anyone, if you need to contact me, you can contact me on Twitter at Aaron Colaço, or you can reach out to me over email at aaron@aaroncolaço.com. Yep, over to you, Sanjit.
Hello. Okay, thank you so much, Aaron, for the wonderful session. I hope all of you were able to take something insightful from this session. Okay, so we have something called as GS Cup. GS Cup is a community-based event that will promote and encourage students who have contributed to any community. It will be awarded to the student who will score the maximum number of points according to the guidelines and contributions he or she has given to the community. For more information, you can visit the GirlScript website, girlscript.tech. Okay, so now as we have come to the end of this event, there will be a quiz of 15 questions. The link is mentioned on the screen as well as in the chat box. The form will be open for the next 30 minutes where you will need to answer minimum 12 questions correctly. If you answer 12 questions correctly, you will be eligible for a certificate. Also, please do not forget to fill the feedback form mentioned in the chat box. Thank you so much everyone for attending and being a part of today's session. And once again, thank you so much Aaron for this beautiful session. All the best to
Pleasure.
everyone for the quiz.
Thank you guys for joining us and good luck for the quiz.